Hello everyone, welcome to Prajim Technologies. My name is Avesh and this is part 2 of the design patterns tutorial. In this session, we will discuss what is Singleton design pattern, Singleton as creational pattern, implementation guidelines, and how do we implement a Singleton class. This is continuation to part 1 of the design patterns tutorial, so please watch part 1 before proceeding. Singleton pattern belongs to creational type pattern. Let's recap what is creational design pattern. As mentioned in the part 1 of the tutorial, Gang of 4 have identified 5 design patterns that belong to creational design type category. Singleton is one among them and the rest are factory, abstract factory, builder and prototype patterns. As the name implies, creational design type deals with the object creation mechanisms. Basically, to simplify this, creational pattern explains us the creation of objects in a manner suitable to a given situation. I hope now you are familiar with creational type pattern. Let's now focus on Singleton design pattern. Singleton design pattern is used when we need to ensure that only one object of a particular class is instantiated. That single instance created is responsible to coordinate actions across the application. If you look at the illustrated diagram, you will see different objects trying to invoke an object instantiated as Singleton. This single instance of the object is responsible to invoke underneath methods or events. Let's look at advantages and guidelines in Singleton implementation. Concurrent access to the resource is well managed by Singleton design pattern. As part of the implementation guidelines, we need to ensure that only one instance of the class exists by declaring all constructors of the class to be private. Also, to control the Singleton access, we need to provide a static property that returns a single instance of the object. Now let's flip to Visual Studio and see this in action by implementing a Singleton class. Let's create a new project and choose console application. Let's name this as Singleton demo. Let's add a new class, name it as Singleton. Let's create a public method, public void print details, which accepts string as the input parameter. Let's just print this message using our console.writeLine. Let's just compile this. For our convenience, we have named this class as Singleton. We have not yet applied any Singleton design pattern principles to this class. Let's see why we need to apply Singleton design principles and how we can apply them for this Singleton class. Now that we have created a Singleton class with print details as a public method, we can invoke that public method from this main program by creating a new object of Singleton. Let's see how to do that. Singleton S1 is equal to new Singleton and then S1 dot print details. Let's just say this is first message. Then if we want to print another message, we just need to say S1 dot print details again. This time let's say this is second message. Let's compile this and let's run this program. Look at that. The program has outputted two statements. This is first message and this is second message. That means we have instantiated only one object and we are able to invoke a print details method. Imagine a situation where we need to invoke print details from different classes of a given project. What we do is we end up creating multiple objects of this Singleton class. Let's say we create the Singleton object for an employee. So let's just change this S1 to from employee. That means we are assuming that we are creating this object from an employee class and then say that employee.print details, and let's change this message as from employee And then let's assume that we need to invoke the singleton object from a student class. We would say from student, and then let's print the details from student, and let's pass the message as from student. Let's compile this. Compilation succeeded, and let's run this program. Look at the output. The output has printed a message from employee and from student. This means whenever we need to create an instance of singleton or invoke the print details method of singleton, we end up creating multiple objects. Let's prove that it has created multiple objects. How do we do that? Let's go back to the singleton class. Let's add a public constructor called singleton, and then let's create a private static incremental variable. We will be incrementing the counter as and when a new instance is created using the singleton class. Now once we increment the counter, let's output the counter value using our console.writeLine and say counter value is counter.toString. Let's compile this application and run this again. Look at that. We ended up creating two instances of singleton class, which is evident from the counter value 2. That means first time when we create the singleton object from employee, the counter value is incremented to 1, and second time when we create another instance of the singleton object, the counter value is incremented to 2. Even though we are invoking a very common method, we are ended up creating two instances of the same singleton class as objects. Now that we have proved it's unnecessary to create new instance of an object for a common methods like print details, let's see how we can avoid that. The first point comes into mind is to restrict the multiple instance creation. We can achieve it by making all constructors as private and change the class to sealed class so that it's not inherited anymore. Let me change to this public constructor to private, and let's also make this class as sealed class as singleton. Let's compile this application now and see the behavior. Look at the error messages here. It says the singleton is inaccessible due to its protection level. Let's see where it is throwing the error. Look at that. For every new object instantiation, it is throwing an error right now. That is because we have changed the public constructor into private, so we are not able to instantiate the class. When we are not able to instantiate the class, we need to provide an alternative way where we can give back the singleton object creation. Let's see how we can create a single instance of this singleton class. Let's create public static singleton, call it as get instance. Return new singleton. Look at that. We have not overcome the problem of creating multiple instances if we return new singleton instance in this get instance property. How do we avoid this? Let's create a new private static singleton. Let's call it as instance, which is equal to null. We need to create an instance only if the above declared private property is null. So let's put the check instance equal to null, then instance is equal to new instance, and then let's modify this code and return instance instead of new instance. With this, we have applied the singleton design pattern to our singleton class. Let's go back to the program and see if the error is gone. No, the error is not gone yet. Reason, we are still trying to instantiate a new singleton class. Let's change it. Instead of doing a new singleton, let's use the property which we have created, which is the get instance. Let's say instead of doing a new instance, now we are getting it from singleton.getInstance. Let's do the same thing for student. Instead of creating a new instance, we have successfully achieved the same behavior through the getInstance property, and this getInstance will take care of creating only one instance of the object across the application. Let's run this application. Look at that. The counter value has not been incremented, and we have got the input from both employee and student as well. This means we have successfully achieved the singleton design pattern with this example. Now let's flip to the singleton class. Based on the given situation, we have successfully changed the object creation pattern of this class by applying the singleton design principles, and we have learned the first base version of the singleton design pattern. You might be wondering why this is the first base version. If you focus on this code, this works perfectly well in a situation when a single thread is trying to create instance of this class. This version is not efficient enough to handle multiple threads, as it will run into a race condition situation. In the next session of this video, we will discuss how to handle this multi-threaded situations as well as a real-world implementation example. Thank you for listening. Have a great day.